Back in 2017, a team of researchers at Google published a paper with a title that was, well, pretty bold and surprisingly simple. Little did anyone know it was about to completely rewrite the rules for artificial intelligence. Today, we're going to crack open that very paper. Attention is all you need, and figure out exactly what made it the spark that ignited the AI revolution we're seeing today. So let me ask you this. When you read a sentence, you just get it, right? You see all the words, how they relate, the whole meaning almost instantly. But have you ever stopped to wonder how an AI does that? How does it actually grasp the entire context of a sentence all in one go?
Well, the crazy answer is that for the longest time, they just couldn't, not really. See, the most advanced AI models had this fundamental handicap. They had to process language sequentially. Think about that. They had to read one single word at a time.
So let's really dig into this one word at a time problem, because understanding this bottleneck is key to understanding why the breakthrough that followed was such a massive deal. All right, so before 2017, if you were doing anything with sequences of data, like say translating text, you were almost certainly using something called a recurrent neural network, or an RNN. These were the go-to models, the tried and true workhorses of the field. I love this analogy. Imagine trying to understand a giant, beautiful painting by looking at it through a tiny pinhole. That's kind of what it was like for an RNN. It sees the word the, then it moves to quick, then brown, then fox. By the time it gets to the end of a really long sentence, it's probably forgotten the beginning. The paper calls this the fundamental constraint of sequential computation, and it was a huge, huge hurdle. And this table from the paper just lays it all out crystal clear. Look at that recurrent row. See how the number of operations in the path length grow with the sentence length n? That means to connect the first and last words, the information has to travel through every single word in between. It's a long, slow game of telephone. But now, look at self-attention. The number of operations is constant. The path length is always just one. That's a direct connection. Instantly. Game changer. And that brings us to the absolute heart of the paper, this incredible breakthrough mechanism they called self-attention. So what in the world is self-attention? Put simply, it's a way for the AI to look at a single word in a sentence, and at the exact same time, look at every other word to figure out which ones are most important for understanding it. It's like creating a web of context for every word all at once. Let's go back to our pinhole analogy. With self-attention, the model basically throws that pinhole in the trash. Suddenly, it can see the entire painting at once. It can draw what the paper calls global dependencies, connections between any two words, no matter how far apart they are. The context is immediate and total. Now, an idea this powerful couldn't just be a minor update. Nope, it became the foundation for a completely new type of AI architecture. Let's take a look inside the machine they built with it, the transformer. And they just lay it all out, right there in the paper's abstract. They say, we propose a new simple network architecture, the transformer, based solely on attention mechanisms, dispensing with recurrence entirely. I mean, think about how radical that was. They took the old way of doing things, that sequential word-by-word process, and just threw it out the window. And here she is, the legendary transformer architecture diagram. Now I know, it looks a little intimidating, but the big picture is actually pretty straightforward. You've got two main parts. The stack of boxes on the left, that's the encoder. Its job is just to read and understand the input sentence. The stack on the right, that's the decoder. It takes that understanding and uses it to generate the new sentence. So inside those big encoder and decoder blocks, you've got the real engines. The truly genius part is what they call multi-head attention. The best way to think about it is this. It's like giving the AI 8 different sets of eyes to look at the sentence, all at the same time. One pair of eyes might focus on grammar, another might track who's doing what to whom. It allows the model to understand the sentence from multiple perspectives at once. Okay, so the theory is cool, the architecture is clever, but did it actually work? Was it better? Let's get to the results, because this is where the transformer really just blew the doors off. This number right here is the proof, 28.4. Now that might not mean much by itself, but in the world of AI research, this was an earthquake. This was the new state-of-the-art score on a key translation test. It didn't just inch past the old record, it soared past it by over 2 whole points. In this field, that kind of leap is practically unheard of. And it wasn't just about a better score. It beat everything, even these huge, complicated models that were basically teams of AIs working together. But here's the real kicker. It did all this while being way more efficient. The paper points out it required significantly less time to train, so it was better, faster, and cheaper to run. That's the trifecta.
So, if we boil it all down, the paper delivered 3 massive wins. 1, it could be massively parallelized, making it perfect for modern computers. 2, that short path length made it way easier for the AI to learn those tricky connections in long sentences. And 3, those 2 things combined led directly to better quality and record-shattering results.
But the impact here wasn't just about setting a new high score in machine translation. No, this paper kicked off a full-blown revolution, a complete paradigm shift for the entire field of AI.
And this is the part that really matters to all of us today. That transformer blueprint we just walked through, it became the fundamental DNA for pretty much every major large language model and generative AI tool that you hear about, from ChatGPT to Gemini and all the rest. They are all, in one way or another, direct descendants of this 2017 paper.
You know, the authors chose a really audacious title for their paper, but in the years that followed, history has proven them right. For this entire era of AI, it really does seem that attention is all you need. Which leaves us with one last, really exciting question to think about. The Transformer has reigned supreme for years. But if attention was the huge, paradigm-shifting breakthrough of the last decade, what's going to be the next one?